Hello everyone, welcome to day 1 of my IGCSE series. In this video, I have included all the possible keywords necessary for your exam. Don't skip the videos in between. And also, I have given a quick summary at the end. Let's begin with alkane. Alkanes are made up of single bond and hence we call it as a saturated compound. It has the general formula CnH2n plus 2. When a compound is made up of carbon and hydrogen atom, we call them as hydrocarbons. When we are naming the compound, the name should start with the root word followed by ane for an alkane. When we have one carbon atom, the root word is meth and the suffix is ane. Carbon can have maximum 4 bonds and this must be filled with an hydrogen. Molecular formula is number of carbon and hydrogen atom. Here we have 1 carbon and 4 hydrogens. So the molecular formula would be CH4. Structural formula is also same for methane. And for ethane, this green one has already 1 bond here. So we need 3 more. 1, 2, 3. And the yellow one already has 1. So we need 3 more. 1, 2, 3. And it must be filled with hydrogen. And when you are writing the molecular formula, just count the number of carbon and hydrogen atom and write. We have 2 carbons and 6 hydrogens. And when we are writing the structural formula, this part, let's take this part as the first part. 1 carbon and 3 hydrogen. So I will write it as CH3 and the other part, green carbon, CH3. Structural formula CH3 and CH3. For propane, we have 3 carbon atom. The root word is prop and the name should end with ane. The green one on the right side has already 1 carbon. Remaining, we need 3 more. And the center yellow one already has 2 lines. So we need 2 more. 1, 2. The left one already has 1 bond in between. We need 3 more. 1, 2, 3. And fill this with hydrogen. And count the number of carbon and write the molecular formula C3H8. And when we are doing the structural formula, make sure to take it part by part. So this part CH3, CH2, CH3 is the structural formula. CH3, CH2, CH3 is the structural formula of propane. For butane, on the right one, already it has 1 bond in between. We need 3 more. 1, 2, 3. And the yellow one already has 2 bonds. We need 2 more. 1, 2. The pink one already has 2 bonds around it. So we need 2 more. On the left side, it already has 1 bond. We need 3 more. 1, 2, 3. Fill this with hydrogen. So remember, whenever always try to start with the carbon and then fill it with hydrogen. Butane molecular formula is C4H10 and the structural formula would be CH3, CH2, CH2, CH3. CH3, CH2, CH2 and CH3. Now pause the video and try for pentane. Hope you got the right answer for pentane. Homologous series is a group of organic compound which has the same functional group. Alkenes are all made up of single bond, whereas alkenes double bond, alcohols with the OH functional group, which means homologous series, they have the same functional group and each member of the series differs by CH2 unit. They all have the same chemical properties, same general formula and a same functional group. The first 4 members of the series would be a gas and the next 4 members would be a liquids. As the molecular size increases, boiling point increases. This is because the strength of intermolecular force of attraction between them would be increased. So we need to give more energy to break the bond. In general, alkenes are unreactive. Again, that is because of the strong force of attraction. Isomers have same molecular formula but different structural arrangements. Number of possible isomers of alkenes. Butane has 2 possible isomers and pentane has 3 possible isomers. Whenever we are trying to draw an isomer, Try with this method. Try to do it like a straight chain and like an inverse T and like a plus. First, I'll try with the straight chain for C4H10. 1, 2, 3, 4. And then fill the remaining by hydrogens. The right corner has already 1 bond, so it needs 3 more. These 2 corners need 2, 2 each. 1, 2, 1, 2. On the left one, 3. Fill this with hydrogen. It has C4H10. And how to draw a structural formula for this? CH3, CH2, CH2, CH3. And then next isomer, I'll try like a inverse T. 1, 2, 3, 1 carbon on the top. Now fill this with hydrogen. This carbon already has 1 bond, so it needs 3 more. 1, 2, 3. The top one again has 1 bond, it needs 3 more. 1, 2, 3. The center one has 1, 2, 3 bonds, so it needs only 1 more. On the left one needs 3. 1, 2, 3. Now fill this with hydrogen. H, H. Let's write a structural formula for this. Alright. First, this part. This carbon is attached to 3 hydrogen. So CH3. The center one, CH. And we have a branch here to this. So this part we will write it like in a bracket CH3 and then this part CH3. Choose the longest chain to name the carbon. So it's propane. To the second carbon we have a methyl group. So the name of this compound is 2-methyl-propane. Pause the video and try for pentane. Now C5H10. Draw a straight chain first. Fill the remaining part by hydrogen. And the structural formula for this would be CH3, CH2, 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 CH3. The name of this compound is pentane. And the next isomer, we'll try like a inverse T. 1, 2, 3, 4 carbon in a straight chain and 1 at the top in the branch. Fill the remaining part by hydrogen. While naming the compound, choose the longest chain. While naming the compound, choose the longest possible chain. Branch should get the lowest possible number. If I name from left to right 1, 2, 3, 4, branch will get 2. In case if I start numbering from right to left 1, 2, 3, 4, branch will get a 3. So we have to start numbering from left to right. 1, 2, 3, 4. Now branch will get 2. So the name of this compound is 2-methyl-butane. And how do we draw the structural formula for this? CH3. And for the second carbon, CH, in a bracket, the branch, CH3, CH2, CH3. And next we will try like a plus for the next isomer. 1, 2, 3 and 2 in the center. Now we will fill the remaining part by hydrogen. 1, 2, 3, 1, 2, 3. On all the other sides we have 3 hydrogens. Now choose the longest chain. This way also it's 1, 2, 3. Or if I take like this also it's 1, 2, 3. It's propane. So I'll number the carbon now. 1, 2, 3. So to the second carbon we have 2 branches now. 1, 2. So we have to name the compound as 2, 2. We have 2 methyl groups. So we use the term dimethyl and the root word propane. 2, 2 dimethyl propane. Burning in presence of oxygen leads to 2 types of combustion. Complete combustion and an incomplete combustion. For a complete combustion to take place, we need a sufficient oxygen. For an incomplete combustion occurs due to lack of oxygen or insufficient oxygen. Remember, for a complete combustion, it always gives out carbon dioxide and a water. For an incomplete combustion, it always gives carbon monoxide or carbon and water. Check out my other videos for balancing or complete and incomplete combustion. Now we'll move to the exam question. Why CO released from incomplete combustion is toxic? This CO will reduce the blood to carry an oxygen. So it leads to a breathing difficulty and eventually death. What is the black solid formed from incomplete combustion? Which is carbon is a black solid. Why incomplete combustion occurs? It occurs due to insufficient oxygen. Reactions of halogens with alkene. For this reaction, the condition is UV light and the type of reaction is substitution. We'll write a chemical equation. Alkane, I'm taking methane, CH4 plus bromine. And always this part, halogen group should be in a diatomic form. 2 should be there. Even if it's a bromine or chlorine, you have to write Br2, Cl2 like that. It gives bromoalkane, CH3Br plus HBr. Let's write a displaced formula for this. 4 hydrogens and we have 2 bromines, which gives, try to, this hydrogen bromide gets removed, it will be like HBr. And here, what is the remaining part? Just ignore this and write the remaining part. CH3Br. Now pause the video and try for ethane with bromine. We have 2 carbons for ethane. Fill the remaining part by hydrogen. And 2 Br. Remove this HBr. The remaining part would be, I'm just removing this. The remaining would be CH3 CHHBr. This is bromoethane, hydrogen bromide, bromine, and this is ethane. Now practice for methane and chlorine and ethane and chlorine with a similar way. Let's move to exam type question. Question A. Explain why all of these compounds are described as hydrocarbon. What are hydrocarbons? Compounds made up of carbon and hydrogen atom only. Carbon and hydrogen only. This question is for 2 marks. Only carries 1 mark. Carbon and hydrogen carries another mark. Why B and E described as unsaturated. Unsaturated means it contains more than 1 bond. In B we have a double bond. E also we have a double bond. So we say it contains double bond. Which letter represents the first member of homologous series of alkenes? So the first member is CH4. The letter A represents the first member of series. Which letter represents the compound that have an empirical formula CH2? CH2 is in the ratio of 1:2. So for this question, find the molecular formula for the given compound. Just count and write the number of carbon and hydrogen. The next one is C3H6, C3H8, C4H10, C4H8, C4H8. So we can clearly see B, E and F are 1:2 ratio. So the answer is B, E and F. Compound F is the general formula of an alkane. Why F do not decolorize bromine water? Remember, alkanes do not. Here it's all single bond. Alkane do not decolorize bromine water. Compound F is an alkane, so do not decolorizes. Question 2. The equation represents the reaction between compound P and bromine. Okay, this reaction is methane with a bromine. So we know this is a substitution reaction. Remove this hydrogen and bromine part and write the remaining answer. So the displayed formula would be CH, H and Br, and this H is here. We have completed the displayed formula. Name the organic product. This is bromomethane. State the condition used in this reaction. Guess the answer. UV light. And what is the term used for this reaction? Type of reaction is a substitution reaction. Alkenes has a general formula CnH2n. It has a double bond and hence we call them as an unsaturated compound. Let's move to a displayed formula. It needs at least one double bond. So it starts with ethene, 2 carbons with a double bond. So now fill the remaining part by hydrogen. The left side already has 2 bonds, so it needs 2 more and fill it with hydrogen. The molecular formula of this compound is count the number of carbon and hydrogen and write your answer. C2H4. Empirical formula is the simplest number. Take the lowest number and divide your answer, or you can just check the ratio CH2. And the structural formula would be CH2CH2. You don't need to show any other bond, but just show a double bond in your answer. CH2 double bond CH2. For a propene, 3 carbons with 1 double bond. This double bond can be on the right side or it can be here. Now fill the remaining part with hydrogen. 2 bonds it needs. The center carbon needs 1 bond. It needs 3 more bonds because it already has 1. Now write the hydrogen. Write the empirical formula, molecular formula, which is C3H6. And the empirical formula would be CH2. Write the structural formula CH3CH2. CH3CH. Here we have a double bond. Write down the double bond and write CH double bond CH2. The displayed formula of for but-1-ene, we have 4 carbons, 1, 2, 3, 4, double bond on any one side. Fill the remaining part with hydrogen. Right side 2, in the center 1, the next one 2, here we need 3. Fill this with hydrogen. Structural formula would be CH3, CH2, CH, CH2. CH3, CH2, CH double bond, CH2. C4H8 is the molecular formula. Empirical formula would be CH2. Isomers are the same molecular formula but different structural arrangements. These are the 3 possible isomers for GCSE. For ethene and propane is just a straight chain. For butene we have 3 isomers. The first isomer is but-1-ene, where the double bond is between first and the second carbon. It is a straight chain. For but-2-ene, the position of the functional group, that is the double bond, is between 2 and 3. So for butene, but-1-ene, double bond is between 1 and 2. For but-2-ene, the double bond is between 2 and 3. There is one more isomer. We'll try like a inverse T with 1 double bond on any side. And fill the remaining part with hydrogen. 1, 2. The center already has 4, so no hydrogen. For the top one, we need 3 hydrogens. For the left side, we need 3 more hydrogens. And when we are naming, the double bond should get the lowest possible numbers. 1, 2, 3. The name of the compound is 2-methyl. In the second position, we have a branch. We have a branch here. So the name of this compound is 2-methyl prop, and the double bond is between first and 2. So lowest number is 1. So prop-1-ene. The name of the compound is 2-methyl prop-1-ene. Addition reaction with bromine. This is an important question. When an ethene or any alkene reacts with a bromine, it changes from orange to colorless because it is an unsaturated compound. And the chemical reaction for an ethene is just draw CH2, and we are reacting with the bromine. Bromine is always in a diatomic state, Br2. We can write it like this. We have 2 bromine atoms which forms. We will not remove anything, just break this double bond into a single bond. So CH, alkene becomes an alkane in an addition reaction. CH, H, and we are adding Br here. So the name of this compound is ethene plus bromine, the chemical equation. Ethene plus bromine gives 1, 2. 1, 2. 1, 2, we have 2 bromine atoms. So we are using the term dibromoethane. Pause the video and try for propene plus bromine. I am writing here. Now, CH3, CH, H, H plus Br and Br. In the similar way, we can add bromine only here to the first and second carbon. So I am not changing the left side part. Br here and 1 Br to the right. Now you can try for butene. And the next equation is between alkene and hydrogen. It is also an hydrogen reaction. This reaction is called hydrogenation. This is also similar to bromine reaction. Ethene, I am writing an equation between ethene and an hydrogen. Just break the double bond. To know the difference, I am giving this hydrogen in a red color. H and H. It is also in a diatomic form. CH, just break the double bond into a single bond. Alkene becomes an alkane and the other H2 gets added to the compound. So this is just ethane, this is ethene and this is hydrogen. Next reaction is an hydration, which is addition of water to an alkene. So any alkene, when they react with water, it forms an alcohol. So what is the product formed from an hydration? It forms an alcohol. And we have a condition for this reaction. Temperature should be 300 degrees Celsius and the pressure should be 60 to 70 atmosphere, and we have a catalyst, phosphoric acid. So I am taking ethene. CH2 double bond CH2 plus water can be written as HNOH, right? So HOH will give CH single bond, CH, break the double bond and add OH and H to the carbon, H and OH. The name of this compound is ethanol. Here the water is in steam state. Okay. Here this is ethene. Let's move to exam type questions. What is the molecular formula of a compound S? Count the number of carbon and hydrogen and write. So we have 5 carbons and 12 hydrogen. What is the empirical formula of a compound T? To find the empirical formula, first find the molecular formula. Here we have C2H4Br2. So if you want to find the empirical formula, take the lowest number. Here the lowest number is 2. Divide all your answer. So it becomes C1. If it's 1, you need not to write the answer. You need not to write 1. C1H2Br1. Give the 2 letters that belongs to an homologous series of alkene. Here we have only 2 alkenes, which is R and U. The answer is R and U. What is the general formula of an alkene of homologous series? General formula of an alkene is CnH2n. Which of these conversion is an addition reaction? For an addition reaction, it should start. We have 2 alkenes here, ethene and propene. If it starts with the ethene, the answer should end with ANE. If it starts with propene, the answer should end with propane. It can't be U because we don't have any other 3 carbon atoms. So obviously it starts with R. From R to Q. When we add a hydrogen to this, it forms a Q compound, ethane. Why it can't be R to T? When we add a bromine to this, our product is supposed to be like this. Br to the adjacent carbon, not attached to the same carbon. So it can't be T. The answer is R to Q. Complete the displayed formula and the name of the isomers of T. Isomers of T. If you are writing the isomer of T, just change the position of bromine. We have 2 carbon and bromine atom. Okay. So draw 2 carbon In the question, bromine is attached to this same carbon. Here for isomer, we are changing the position to the adjacent carbon. Br, H, H, H. And the name of this compound is 1,2 dibromo. We have two bromine. Dibromoethane. Crude oil is a mixture of hydrocarbon formed from remains of dead plants and animals over millions of years, which is a non-renewable resources, and remember it is made up of only hydrocarbons. Physical properties. As the chain length increases, boiling point would increase. That is because the strength, intermolecular force of attraction would be more. So we need to give more energy to break the bond. And they become less volatile. As the chain length increases, they become less volatile. Volatile means easy to evaporate. Again, this is because of the strong bonding between them. Viscous. Viscous is the thickness. As the chain length increases, they become more viscous and they become more darker. The bigger molecule will not catch fire easily. Fractional distillation. Crude oil is separated using a fractionating column. Once it's into the chamber, it gets vaporized and condenses at various levels. The lower chain alkenes is a lower boiling point and get collected at the top of the column. The one with the higher longer chain will get collected at the bottom of the column. Try to remember the order and learn one uses of each. Refinery gases is used for a domestic cooking. Gasoline is used for cars and kerosene is used for a aircraft. Diesel is for cars, buses, etc. and fuel oil is for ships. Bitumen is for road surfacing. Cracking. Cracking is used to convert a longer chain alkane into a shorter chain alkane and alkene. The condition for this reaction is 600 to 700 degrees Celsius, and the catalyst used for this reaction is silica or aluminum, or it can be called as a silicon oxide or a aluminum oxide. And why do we need a cracking? Because the shorter chain alkanes are more in use, like it can be used as a fuel. Alkene can be used to make a polymer. Acid rain. Impurities like sulfur from burning of fuel will react with O2 to form sulfur oxide, which reacts with H2O to form sulfuric acid. And impurities from car engines like nitrogen will react with oxygen in the atmosphere forming nitrogen dioxide, which reacts with H2O to form nitric acid. Learn the effects of acid rain. It changes the pH of the soil and can kill trees, and it can change the pH of water and can affect the aquatic life, and it can corrode the limestone buildings. Let's move to an exam type question. Octane is an alkene that is present in petrol, and we need to write a complete combustion of this alkene, and it gives carbon dioxide and water. Octane formula is C8H18, which is given in the question, and they say it reacts with oxygen forms carbon dioxide and water. Oxygen forms carbon dioxide and water. To balance this reaction, start balancing from carbon, hydrogen and oxygen. So here we have 8 carbon. So I'll put 8 in front of CO2. And then we have 18 hydrogen. So we need to put 9 here. 9 in front of water. Now how many oxygens do we have? 8 times 2, which is 16, plus 9 times 1, which is 9, which is 25. So we have 25 oxygens on the right side. We need to make half of this, which is 12.5. Either you can give your answers in decimal or you can twice your answer. Like 1 becomes 2. 2C8H8 plus 25O2 gives 16CO2 plus 18H2O. Both your answer is right. Next one. Give the name of the toxic gas produced from an incomplete combustion. Toxic gas is carbon monoxide. You can write carbon monoxide. Describe how the catalyst alters the speed of a reaction. So catalyst provides an alternative pathway. It provides an alternative pathway by lowering its activation energy. Pathway by lowering its activation energy. Activation energy is the minimum energy required for a chemical reaction to take place. Give the name of a suitable catalyst for this reaction. It can be silica or alumina. You can give silica or alumina, or you can give aluminum oxide or silicon dioxide. Complete the equation that represents the reaction. So we know one of the product is an alkene, the other product is a alkene. First subtract these two and write the answer here. C12 minus 8, which is 4. 26 minus 18, which is 8. Since we already have 2 here, just of this value, it becomes C2H4. Give the name of the other product. C8H18, which is octane, we know from the formula. The other compound is this, which is ethene. C2H4. Here is a quick summary of alkane, alkene and crude oil. If you find this video useful, like and subscribe for more videos.